This video will take you through the steps for solving an exponential equation and solving logarithmic equations. And they are a little tricky, but the part that's tricky is recognizing how you're supposed to start. So let's look at some generalities here for the steps for solving exponential equations. First, if you can, you want to obtain the same base on either side. And we've actually done some of those like that, and I'm going to show you another one. If you can't obtain the same base, isolate the term that is exponential. I'll show you what that means in a minute. And then take the log or ln of both sides, use a property of logs, and solve for the variable. All right, we're going to begin with one that we can obtain the same base on either side. So let's look at this general rule again. Remember that if a to the u equals a to the v, in other words, the bases are the same, then the exponents have to be the same. That's just common sense. So if I can take the 81 and make it be a base of 3, in other words, if it's a power of 3, then this will be easy to do. So I'm going to say 3 to the x plus 1 equals, and I can do that. 81 is the 4th power of 3. So now you can see my bases are the same. So based on this property, I know that my exponents have to be equal. So x plus 1 has to be equal to 4. This is a very easy one. And I solve for x by saying subtract 1, and I get x equals 3. It's just a regular old equation. Next one is a little trickier. I have e to the negative x squared equals e to the x to the second times 1 over e cubed. So how are we going to get just two separate e's on each side with the bases the same? Well, I need to do some simplifying over here. This first one is fine. So I've got e to the negative x squared equals, first thing I can do here is use my exponent rules. That's 2x times 1 over e cubed is e to the negative x squared. That's e to the negative x squared. Now, how do we multiply like bases? Think about it. I multiply, if I have e over 1, I would just have e to the 2x. Let me do this up here. E to the 2x over 1 times 1 over e cubed is going to be e to the 2x minus 3. So I can change this to 2x minus 3. So it actually was fairly simple to get my bases the same. You just had to remember your old exponent rules, that when you divide like bases here, you subtract their exponents. And now I can set their exponents equal to each other. So negative x squared equals 2x minus 3. Now what are we going to do with this? Because I have an x squared, it's going to be quadratic. I am going to get it equal to 0 by adding an x squared to both sides, and I get 0 equals x squared plus 2x minus 3. And now guess what you have to do? You have to factor. It didn't go away. You're looking for factors of negative 3 that add up to positive 2. Those are going to be positive 3 and negative 1. So x plus 3 times x minus 1 equals 0. X plus 3 equals 0, or x minus 1 equals 0. And x equals negative 3, or x equals positive 1. So old stuff came into play here. Things that, in order to get the bases the same on either side, you had to go back to old rules that you knew about division of unlike bases, subtracting their exponents, and then factoring and using the zero factor property. So you don't want to forget those old things because they do come into play. All right, let's look at C. This is one where I cannot make the bases the same. 5 is not a power of 2. So there's nothing I can do to turn that 5 into a 2 to this something. That isn't going to work. And since it's not going to work, we're going to take the ln of both sides. I always take the ln instead of the log. Maybe it's just laziness because I only have to write 2 letters. I don't know. It just seems easier. Now, what do we know about an exponent? I can get it on the ground by bringing it around as a factor. So x ln of 2 equals ln of 5. To solve for x, I'm going to divide both sides by ln of 2, and I get x equals ln of 5 over ln of 2. Honestly, I think these are easier in some regards. Now, if you wanted to know what that was, put it in your calculator. It's approximately 2.32. I don't care about that. I care about this, that you know how to get there. So if you can't get bases the same, we isolated, it was already isolated, the exponential factor, our term, and then we took the ln of both sides. Let's look at this one. I can't get a 5 to be a 3 to some power, and there's an 8 in the way. So the first thing I have to do is isolate the exponential term. So that gives me 3 to the x equals 5/8. I definitely can't get those to the same base, so I'm going to take the ln of both sides and then bring the x down. So I have x ln of 3 equals ln of 5/8. Now let me make a little note here. ln of 5/8 is not the same thing as ln of 5 over ln of 8. If you don't believe me, put it in your calculator and you'll see. So be careful how you write these. Now I have to divide by ln of 3, and I get x equals, this is very awkward, but it's very accurate, ln of 5/8, get some answer, divided by ln of 3. Now this is the answer I want, but just to make sure you are able to enter that in your calculator and get the correct answer, I want you to try entering it, and what you should get is negative 0.428. And I'm going to grab my calculator and show you how to enter that, because students do work correctly and then are unable to enter that in a calculator accurately. So here's what you would want to do. Let me see if I can get these all on here together. Yeah, okay. We want to say ln of 5/8 first. So you're going to go to your ln button, ln parentheses 5 divided by 8, close parentheses. I always hit enter. And then I'm going to take that answer and I'm going to divide it by ln of 3. ln of 3, close parentheses, and I get negative 0.4278. I rounded off. Negative 0.428. So just make sure that you are comfortable entering those in a calculator to get the right answer, because on application problems, you actually will have to get a decimal equivalent. All right, let's look at this one. First thing you want to do, you want to isolate this. So we're going to divide by 5. That's going to give me 2 to the 3x equals 8/5. I certainly can't get the bases the same, so I'm going to take the ln of both sides. I'm going to bring the 3x down to the front, so 3x ln of 2 equals ln of 8/5. Now you've got to be really careful here. Just realize that this is 3 times x times ln of 2. It doesn't matter what order. So if I want to solve for x, I can divide by 3 ln of 2, because those are going to cross cancel. 3 ln of 2. And I get x equals, we're going to simplify a little bit more, ln of 8/5. But let's just look at this part for a second. 3 ln of 2. Take that back up, and that's ln of 2 to the 3rd, which is ln of 8. So I'm going to say divided by ln of 8. Again, put that in your calculator and make sure you can get 0.226. This is the answer I will be looking for, however. All right, let's look at this last one of the exponential equations. We have 3 to the 1 minus 2x equals 4 to the x. I can't get 3 and 4 as the same base, because 4 is not a power of 3, or vice versa. So I'm going to take the ln of both sides. Ln of 3 to the 1 minus 2x equals ln of 4 to the x. Now we're going to bring the exponent around the front. 1 minus 2x ln of 3 equals x ln of 4. Now there's a lot going on here because there's x's everywhere. I'm actually going to go ahead and distribute ln of 3. So ln of 3 times 1 is ln of 3. ln of 3 times minus 2x is minus 2x ln of 3 equals x ln of 4. Now what I want to do is I want to get the terms that contain my variable, the x, on the same side of the equation. So I'm going to add 2x ln of 3 to x ln of 3, just like you do in any equation. We get ln of 3 equals x ln of 4 plus 2x ln of 3. Now, what do you always do when you are trying to solve for a variable and you have two of them and you want to get down to one? You factor. So ln of 3, factor out the variable that you are looking for, and you're left with ln of 4 plus 2 ln of 3, which we just did right here. We had 3 ln of 2. So 2 ln of 3, bring that, is 3 ln of 3 squared, or ln of 9. So I have ln of 3 equals x times ln of 4 plus ln of 9. Now how do I finish solving by x? I divide both sides by this. And yes, it's messy. I'm going to continue it down here. And I get x is equal to ln of 3 over ln of 4 plus ln of 9. Right there you go. That one was kind of massive. All right, those are exponential equations. Let's take a look at logarithmic equations and the steps for solving logarithmic equations. First, you want to use algebra and log properties to isolate the log terms. And then logarithmic functions are one-to-one. Therefore, the log base a of m equals log base a of n implies that m equals n. So you try to get the logs the same and then solve. On these, there's a fourth step. You must check your solutions because some of them don't work. So it says, remember, y equals log base a of x is the same thing as saying that base a raised to the y is equal to x. So here we go. Log base 3 of 4x minus 7 equals 2. What we're going to do is we're going to rewrite this as an exponential. So take your base, raised to the second power, equals the result, 4x minus 7. Well, 3 squared is 9, and now this is a really easy equation to solve. It's just a regular old equation. So 4x equals 16, divide by 4, x equals 4. Now, we have to check and make sure that when we take that 4, let me do this in a different color. Let's use green here. When I take this answer and I put it back up here, I have to get something that's greater than 0. So 4 times 4 is 16 minus 7 is 9. That's fine. I can't have a negative number up there. And we didn't, so we're good. So that was an easy one. We just rewrote it as an exponential. We're going to do the same thing here. We're going to say x squared equals 64. Now how would I solve that? I would take the square root of both sides. X equals plus or minus 8. Can x be both a plus 8 and a minus 8? Yes, because I'm using it as a base. Can you have a negative base? Think about it. Can you have a negative base? If x is negative 8, can I say log base negative 8 of 64 is 2? Let's see. Log base negative 8 of 64 is 2. That would mean negative 8 squared is equal to 64. So we can have it. All right, let's look at this next one. E to the 2x equals 52. I can't rewrite that exponentially because it already is, so we're going to use logs to solve it. We're going to take ln of both sides, but ln and e make a 1, and it brings that 2x down, equals ln of 52. So now all I have to do is divide both sides by 2. Now be very, very careful. This is not equal to 26. It's ln of 52 divided by 2, not ln of 52 divided by 2. Put that in your calculator and make sure that you can get 1.98 because that's what it should equal approximately. In D, I have 2 log base 5 of x equals log base 5 of 9. Well, I have a log base 5 and a log base 5. So if I could get those exactly alike, then I could set the two pieces equal to each other. So I'm going to bring this up and say x squared equals 9. Now I'm going to take the square root of both sides. X equals plus or minus 3. But just like we did up here, let's check. Can I take the log? X here is my result. Can I have a negative result? I can't. So x cannot be negative 3. So all we have is x equals positive 3. Last two are pretty tricky. So let's take a look. Log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. Well, I'm going to use my log rule. As soon as I see plus and the two logs are the same, I know multiply. So it's going to be log base 5 of x plus 6 times x plus 2 equals 1. Or log base 5. Now let's FOIL this out, and you're going to get x squared plus 8x plus 12 is equal to 1. And now I'm going to write it exponentially like we did here and here. So I'm going to write 5 to the first power equals x squared plus 8x plus 12. Well, that's just 5. So I'm going to subtract a 5 from both sides because I see I have a quadratic and I need to get it equal to 0. Now I have to factor. And I'm going to get x plus 7 times x plus 1 equals 0. So x equals negative 7 or x equals negative 1, but we have to check. Let's check negative 7. If I take negative 7 and I go back up here and I said negative 7 plus 6, I would be taking the log of something negative, and you can't. So I have to get rid of that. If I put in a negative 1, it's going to be fine in either spot. So x is only equal to negative 1. Last one, ln of x plus ln of x minus 4 equals ln of x plus 6. Well, again, here's a plus, so I know I can multiply. So it's going to be ln of x times x minus 4 equals ln of x plus 6. We're going to distribute. Ln of x squared minus 4x equals ln of x plus 6. Since they're both ln's, I can set the results equal to each other. X squared minus 4x equals x plus 6. It's quadratic. Let's get it equal to 0. And I get x squared minus 5x minus 6 equals 0. So I need factors of negative 6 that add up to negative 5. That's negative 6 and positive 1. So x minus 6 times x plus 1 equals 0. So set each of those equal to 0 using zero factor property. And you get x equals 6 or negative 1. But go back up to the top. ln of x. Can I take ln of a negative? No. So my answer is just x equals 6.